Hi friends, welcome to the next session of the subject Engineering Mathematics. Now in this session, we discuss classroom workbook questions based on the concept eigenvalues and eigenvectors. Now let us start this session with question number 42 in your handout. Just go through question number 42. So what it is? One of the eigenvalue of the matrix, question number 42. One of the eigenvalue of the matrix A equal to 2, 7, 10, 5, 2, 25, 1, 6, 5. One of the eigenvalue of this matrix is minus 9.33. First off, one of the other eigenvalues of A is, it is a 3 by 3 matrix. One of its eigenvalue is given as minus 9.33 and they were asking one of the remaining eigenvalues. If it is a 2 by 2 matrix, when you apply trace property, lambda 1 plus lambda 2 equal to trace and lambda 1 is this minus 9.33, you can easily get lambda 2 value. But this is a 3 by 3 matrix. So let us try to find remaining eigenvalues. Now in the options, two numbers are real numbers and two numbers are complex numbers. Option A is 18.33, B minus 18.33, but C is a complex number and D is a complex number. Interestingly, C is a complex conjugate of D. Now this is a real matrix. Inside this matrix, all numbers are real. So it is a real matrix. Therefore, if something is a real matrix, if a complex number is an eigenvalue, then its conjugate becomes an eigenvalue. If C is right, then D must be right. If D is right, then C must be right. So two right options should not be there in a particular question. Therefore, C and D should not be right. So answer can be either 18.33 or minus 18.33. Now let's trace out. When you look at this matrix, here 2 times of 5 is 15, 5 into 5 25, 1 into 5 is 5. That means column 3 equal to 5 times of column 1. Third column is 5 times of this. So when one column is a constant multiple of another column, then delta of this matrix is 0. When delta of this matrix is 0, one of its eigenvalue is 0. But 0 is not there in options, right? Therefore, one eigenvalue is minus 9.33, call it as lambda 1. Second eigenvalue, I call it as lambda 2. Now let us find lambda 3. So sum of eigenvalues equal to trace. Lambda 1 plus lambda 2 plus lambda 3 equal to trace of this matrix. But lambda 1 is minus 9.33. Lambda 2 is 0 plus lambda 3 equal to the trace of this matrix is sum of diagonal elements 2 plus 2 plus 5. This is 9. Therefore, this implies lambda 3 equal to 18.33. 18.33. So, interesting point is third column is 5 times of column 1. So, det is 0. When det is 0, at least one eigenvalue is 0. If 0 is there in options, you can opt it. But 0 is not given. Therefore, we need to find third eigenvalue lambda 3. So by applying sum of eigenvalues equal to trace property, we got 18.33 is one of its remaining eigenvalues. Note this. I think this is clear, right? Now let us move to question number 43. Just go through question number 3. The minimum eigenvalue of the matrix is, what is my matrix? 3, 5, 5, 5, 12, 7, 2, 7, 5. The minimum eigenvalue of this matrix is, if it is 2 by 2 matrix, handling this is very simple. But this is a 3 by 3 matrix. Interestingly, they were asking minimum eigenvalue. Let us see in this case, this 5 is nothing but 2 plus 3. 12 is 5 plus 7. 7 is, this is actually 2. This is 2. Therefore, 3 plus 2 is 5. 5 plus 7 is 12. 5 plus 2 is 7. Please make changes in your handout. This is 2. Now you can see here R2 equal to R1 plus R3. R2 equal to R1 plus R3. Now this is nothing but linearly dependence relationship among rows. Assume that this matrix is A. Since because of this linearly dependence relationship, det value is 0. When det is 0, at least one of its eigenvalue is 0. But we don't know whether 0 is the minimum eigenvalue of this matrix or not. Whether 0 is the minimum eigenvalue of this matrix or not. Because I should know about remaining two eigenvalues. Here assume that lambda 1 is 0. One eigenvalue is 0. So I don't know what is lambda 2 and what is lambda 3. Now they are asking minimum of lambda 1, lambda 2, lambda 3. If you go through options, in the options there are no negative numbers. The numbers less than 0 are negative numbers. If at least lambda 2 or lambda 3 is a negative real number, that could be minimum of all the eigenvalues. But luckily there is no eigenvalue, there is no negative eigenvalue in the options. Therefore 0 could be negative or least eigenvalue, right? So if either lambda 2 or lambda 3, let me explain once again. So they were asking largest eigenvalue of this matrix. Now in this case there is a relationship among rows. R2 equal to R1 plus R3. R2 equal to R1 plus R3. Therefore, when there is a linearly dependence relationship among rows, det becomes 0. When det is 0, at least one of the eigenvalues is 0. So assume that lambda 1 is 0 and remaining two eigenvalues are lambda 2, lambda 3. If either lambda 2 or lambda 3 is a negative number, then the minimum of all the three values is that negative number. But there is no negative number in the options. Therefore, ultimately 0 is the least eigenvalue of this matrix. Suppose if it is 5, suppose in the question if it is 5, then there is no logic in that, then you need to find entire characteristic equation. So you will get a third degree polynomial expression. So you need to find the roots of that third degree characteristic equation. So you will get lambda 1, lambda 2, lambda 3 and then you can guess what is the least eigenvalue, right? Now let us start question number 44. The eigenvalues of the matrix minus 1, 3, 5, minus 3, minus 1, 6, 0, 0, 3. The eigenvalues of this matrix are given. Options are given. Assume that this matrix is A. What is the trace of this matrix? Sum of diagonal elements minus 1 plus minus 1 plus 3. This is 1. Now let us find the delta of this matrix. Expanded by using last row because last row contains majority number of zeros. So this is a 3 into determinant of this 2 by 2 submatrix. Minus 1, 3, 3. So this is minus 3, minus 1. Therefore in this case this is a 3 into, this is minus 1 into minus 1. 1 plus this is 9. So therefore this is 30. So trace is 1 and det is 30. Now let us go through options. When you add all the elements in the first option, you never get 1. So A is wrong option. Trace property is getting violated. Let us come back to B. So here also trace you won't get like this. Even with C also trace property fails. So ultimately D is right. Just by using trace, when you add all the numbers in the first option, in the second option and in the third option you won't get 1. So add 3 numbers in the first option, add 3 numbers in the second option, add all the values in the third option, you never get 1. So trace property is getting failed for option A, B and C. So just by using trace only, we can say that the answer is D. A, B, C are eliminated. D is right answer. That is by using trace or det. Or if I use the property, earlier I mentioned this. If alpha plus I beta is an eigenvalue of a real matrix A, implies alpha minus I beta is also an eigenvalue of same real matrix A. Now let us apply this rule. In the first option, 6 minus j is there. If 6 minus j is the correct eigenvalue, its conjugate 6 plus j becomes an eigenvalue. In that case, this matrix will get 4 eigenvalues. That should not be happened for a 3 by 3 matrix. The same case with B also. In B, we have minus 6 plus 5j. If it is the correct eigenvalue, its conjugate minus 6 minus 5j becomes another eigenvalue. So in that case, again you get 4 eigenvalues. So that should not be happened. In option C also, if a 5 plus j is an eigenvalue, 5 plus j, then 5 minus j becomes an eigenvalue of same matrix. Again, by that case, you will get 4 eigenvalues for a 3 by 3 matrix. Therefore, A, B, C are wrong. Therefore, D is right answer. Now, let us move to question number 45. The smallest and largest eigenvalues of the matrix 3 minus 2 2, 4 minus 4 6, 2 minus 3 5. They were asking smallest and largest eigenvalues of this matrix. Let me write options. Option A is 1.5, 2.5, B 0.5, 2.5, C 1.0, 3.0, option D 1.0, 2.0. Now let us try to solve this equation by verifying options. If all eigenvalues are given, instead of asking this question, smallest and largest, the eigenvalues of this matrix are option A, 3 eigenvalues, B, 3 eigenvalues, like this. If all eigenvalues are given either by trace or det property, you can get the answer easily. But here for a 3 by 3 matrix, they were asking largest and smallest eigenvalues. Now let us see, in this case, assume that this matrix is A. So trace of this matrix is, add the diagonal elements. So 3 plus 5, 8, 8 minus 4, this is 4. Let us calculate det of this matrix by using any row. So therefore this is plus, minus, plus. So 3 into det of this, minus 20 plus 18. This is already minus symbol is there, it is minus. So you will get plus 2 into 4 into 5, 20 minus 12 plus 2 into 4 into minus 3, minus 12 plus 8. So this is 3 into minus 2 plus 2 into 8 plus 2 into minus 4. So this is minus 6 plus this is 16 minus 8. So therefore 16 minus 14, this is 2. Therefore in this case, trace value is 4 and det value is 2. Therefore, what is my trace? Trace is sum of eigenvalues. So lambda 1 plus lambda 2 plus lambda 3 equal to trace of this matrix is 4. Det of this matrix is lambda 1 into lambda 2 into lambda 3. Det is 2. Now, let us try to verify these options. Suppose if A is right answer. Suppose if A is the right answer. That means if this is one eigenvalue, this is another eigenvalue. Then 1.5 plus 2.5 plus lambda 3 equal to 4. In that case, lambda 3 is 0. So when one eigenvalue is 0, det becomes 0. But here interestingly, det value is a non-zero number. So if option A is right answer, if one eigenvalue is 1.5, second eigenvalue is 2.5, according to this to trace equation, I call it as equation 1 and this is equation 2. So according to equation 1, if I substitute 1.5 and 2.5, I am getting lambda 3 0. So when one eigenvalue is 0, det becomes 0, but here det is a non-zero number because product of eigenvalues is det. Therefore, A is wrong option. Now let us go back to this second option, 0.5, 2.5. Let us substitute these values here. 0.5 plus 2.5 plus lambda 3 equal to 4. In that case, lambda 3 must be 1. Therefore, my eigenvalues are 0.5 means 1 by 2. This is 5 by 2 and this is 1. So therefore, when you multiply lambda 1 into lambda 2 into lambda 3, you never get 2. You never get 2. So substitute second option values in the equation number 1, you get lambda 3 equal to 1. So one eigenvalue is 0.5, 1 by 2. Second eigenvalue 2.5, 5 by 2. Third eigenvalue 1. If B is right option, then third eigenvalue is 1. Then when you multiply all the three eigenvalues, we are not getting 2. Therefore, B is wrong answer. Now come back to option C. So 1.0 plus 3.0, already 4 is covered. So if it is 1, if it is 3, 1 plus 3 is 4, already 4 is covered. So lambda 3 must be 0. If lambda 3 is 0, that should be 0, but that is non-zero. Therefore, option C also wrong. Therefore, D is right answer. Therefore, just by finding trace and det, here also we got the answer. So always you give the priority for those 7 points. Sum of eigenvalues, product of eigenvalues, eigenvalues of multiples of A, powers of A, adjoint, inverse, A plus or minus Ki. So try to follow all those points. You can solve any question very, very easily. Therefore, in this case, when you try to verify trace property as well as det property, A, B, C are wrong options. Therefore, D is right answer. Note these points. Is this question clear? Just by verification of options with the trace and det properties. Let's go through question number 46. Let A be a 3 by 3 real matrix. Sorry, P is a 3 by 3 real matrix. So two of its eigenvalues are, one eigenvalue is 2 plus square root of minus 1 and another is 3. They were asking det P, determinant of P. So what is the matrix? P is a 3 by 3 real matrix. When something is a real matrix, then if the complex number is an eigenvalue, its conjugate becomes an eigenvalue. But only two eigenvalues are given. They were asking det of this matrix. If a total matrix is given, if whole matrix is given, so this is lambda 1 and this is lambda 2, you can easily get lambda 3 by using trace. Lambda 1 plus lambda 2 plus lambda 3 equal to trace. This is lambda 1, this is lambda 2, then you will get lambda 3 if the matrix is given. But matrix is not given. Instead of giving the whole matrix, just they have given us P is a 3 by 3 real matrix. Size is mentioned. Size indicates that the number of its eigenvalues. But only two eigenvalues are given. But one is complex eigenvalue. And the clue point in this problem is it is a real. This is a complex number. Therefore, they were asking det of P. Basically, this det P is lambda 1 into lambda 2 into lambda 3. Now, what is lambda 1? One eigenvalue is 2 plus square root of minus 1. Basically, I square equal to minus 1. Therefore, I equal to plus or minus root over minus 1. So, in place of square root of minus 1, you can write plus or minus I. So, one eigenvalue is 2 plus I. So, when a complex number is an eigenvalue of real matrix, its conjugate becomes an eigenvalue of same matrix. So, second eigenvalue is 2 minus I. And third eigenvalue is given as 3. Therefore, apply this property. So, this is 2 plus I into 2 minus I into 3. So this is 5 into 3 and this is 15. Question number 47. Given that A is a 3 by 3 real matrix such that det of A minus I equal to 0. Trace of A equal to 13. Det A equal to 32. What they are asking? Sum of squares of eigenvalues of A. This is 3 by 3 matrix. So 3 by 3 matrix will have 3 eigenvalues, lambda 1, lambda 2, lambda 3. They were asking lambda 1 square plus lambda 2 square plus lambda 3 square. We need to find out this. So here A is a 3 by 3 real matrix. 3 by 3 real matrix. And 3 equations are given. One equation is the det of A minus I is 0. Trace of A is 13. Det A is 32. Then we need to find lambda 1 square plus lambda 2 square plus lambda 3 square. So therefore we need to find what is lambda 1, what is lambda 2, what is lambda 3. Now let us see. Basically this is characteristic equation. This is nothing but characteristic equation. So therefore the roots of this equation is an eigenvalue. So it is in the form det of A minus lambda I equal to 0. Now lambda is nothing but eigenvalue. So in place of lambda we have constant 1. Therefore from this lambda 1 equal to 1 just by definition. Now apply trace property. Trace is sum of eigenvalues. Lambda 1 plus lambda 2 plus lambda 3 equal to 1. But lambda 1 is 1. So substitute here 1 plus lambda 2 plus lambda 3. Trace is 13. So this is nothing but 13. So lambda 2 plus lambda 3 equal to 12. This is equation 1. Next apply this det property. Det is product of eigenvalues. Lambda 1 into lambda 2 into lambda 3 equal to det is 32. But this lambda 1 is 1. So lambda 2 into lambda 3 equal to 32. This we call it as equation 2. Sum of two numbers is 12. Product of same numbers is 32. So they are 4 and 8. 4 plus 8 12. 4 into 8 32. So one eigenvalue is 4 and another eigenvalue is 8. So lambda 1 we got as 1 and lambda 2 equal to 4 and lambda 3 equal to 8. So square all these values. Lambda 1 square plus lambda 2 square plus lambda 3 square. This is 1 square plus 4 square plus 8 square. The result is 81. Now let us move to question number 48. Consider a 2 by 2 non-singular matrix A. A is a 2 by 2 matrix whose det is non-zero. This is given. And trace of A is 4. Trace of A square equal to 5. Trace of A is 5. A is 4. Trace of A square equal to 5. Then they were asking det A. Det of A. Since it is a 2 by 2 matrix, it has two eigenvalues, lambda 1, lambda 2. So therefore, det of this matrix is product of eigenvalues, that is lambda 1 into lambda 2. So this information is given. A is a 2 by 2 matrix. It is a non-singular, that is det not equal to 0. Its trace is 4, trace of A square is 5. Then they were asking det of this matrix. Basically, det is product of eigenvalues. Now, based on this and this information, let us try to find what is lambda 1, what is lambda 2. Now, here, trace of A means sum of eigenvalues. Lambda 1 plus lambda 2 equal to 4. Now, here, trace of A square. If lambda 1, lambda 2 are eigenvalues of A, then lambda 1 square comma lambda 2 square or eigenvalues of A square, because these two are eigenvalues of A. What are the eigenvalues of A square? Lambda 1 square comma lambda 2 square. If these two are eigenvalues of A square, the trace of A square is sum of these two. So trace of A square means lambda 1 square plus lambda 2 square. This is given as 5. So we need to find lambda 1, lambda 2. Now you can see, let us try to establish a formula. Lambda 1 plus lambda 2 whole square. This is nothing but lambda 1 plus, basically this is lambda 1 square plus lambda 2 square plus 2 lambda and lambda 2. But lambda 1 plus lambda 2 is 4. 4 square equal to lambda 1 square plus lambda 2 square is 5 equal plus 2 lambda 1 lambda 2. This implies 2 lambda 1 into lambda 2 equal to 16 minus 5, 11. This implies lambda 1 into lambda 2 equal to 11 by 5. This is 5.5. So it is given that you need to find answer up to 1 decimal place. So the required answer is 5.5. Now let us move to question number 49. Very interesting question. Given that A equal to 1, 4, A2. One element is not given. The eigenvalues of A are real and non-negative. For 4 options are given. So eigenvalues are real. No eigenvalue is complex. Both the eigenvalues are real. It's a 2 by 2 matrix, so you get 2 eigenvalues. Both must be real. And second condition is both are non-negative. So they should not be negative. They can be 0, they can be 0, they can be positive, they should not be negative. So 2 conditions are given. One is real eigenvalues, second one is non-negative. Interestingly, when you look at all options, every option is a combination of 2 inequalities. Equation contains less than or equal. In all the options, just you go through these options of 49th question. So in every option, you have 2 inequalities with less than or equal. One equality you will get when you apply real eigenvalues. One equality you will get when you apply for non-negative eigenvalues. Right? Now let us see how to find out this. Let us find the eigenvalues of this matrix by using characteristic equation. Det of A minus lambda equal to 0. So subtract lambda only from diagonal. Det of 1 minus lambda for A, 2 minus lambda equal to 0. This implies 1 minus lambda into 2 minus lambda minus 4A equal to 0. This implies lambda square minus 3 lambda plus 2 minus 4A equal to 0. Now this is my characteristic equation. So therefore let us find its eigenvalues by applying square root of minus b plus or minus square root of b square minus 4ac by 2a. Here a value is 1, quadratic expression. B value is minus 3. A value 1, B value minus 3. C value is 2 minus 4a. Therefore the eigenvalues are like this. I am applying the formula minus b plus or minus square root of b square minus 4ac divided by 2a. So therefore this is minus, already b is negative. So therefore this is 3 plus or minus b square 9 minus 4 into a is 1, c is 2 minus 4a whole divided by 2a. So this is 2. So therefore this is 3 plus or minus square root of 9 minus 8. This is 1. 1 plus 16a divided by 2. So therefore one eigenvalue is lambda 1. This is with the plus sign. 3 plus square root of 1 plus 16a divided by 2. Second eigenvalue is lambda 2 equal to 3 minus square root of 1 plus 16a divided by 2. Now I got both the eigenvalues. Now let us try to apply the condition for real eigenvalues. Both eigenvalues must be real. When you look at this is normal evaluation. See, I did simply simplified the characteristic equation, nothing else. Det of a minus lambda I equal to 0. I got a second degree equation. I have applied this formula so that I got two eigenvalues. One is with plus in between this, another is with minus. When you look at this and this, both must be real. Inside square root 1 plus 16a is there. 1 plus 16a is there. If 1 plus 16a is a negative, square root of negative gives complex values. Therefore, to get real eigenvalues, this 1 plus 16a must be greater than or equal to 0. Got it? If 1 plus 16a is a negative, if this is a negative number 1 plus 16a, square root of negative number gives complex values. But you must get real eigenvalues. Therefore, this must be greater than or equal to 0. Therefore, to get real eigenvalues, this 1 plus 16a is greater than or equal to 0. This implies 16a is greater than or equal to minus 1. This implies a is greater than or equal to minus 1 by 16. We can write this in this manner also. Minus 1 by 16 less than or equal to a. So this is the condition to get real eigenvalues. Minus 1 by 16 less than or equal to a. Now, what is when you look at the options, minus 1 by 16 less than or equal to a, that is present in two different options, option B and D. Minus 1 by 16 less than or equal to a, that is present in two different options, option B and D. That means A and C can be eliminated. Answer can be either B or D. Now let us apply for non-negative. Non-negative. Now let us see. Here this is square root of 1 plus 16a. This is square root of 1 plus 16a. Suppose if this value is or this value, because here minus symbol is there and this is with plus symbol. Now what I mean to say is, this square root of this value, square root of 1 plus 16a is at most 3. Maximum value of this square root of 1 plus 16a is at most 3. Suppose if it is greater than 3, if this value is greater than 3, 3 plus greater than 3 divided by 2 is positive value. 3 minus greater than 3, you will get negative value. So therefore, eigenvalues must be either positive or 0. Therefore, to get non-negative eigenvalues, this square root of 1 plus 16a is at most 3. Therefore, square root of 1 plus 16a is at most 3, less than or equal to 3. Squaring on both sides, 1 plus 16a is less than or equal to 9. So 16a is less than or equal to 8. So a is less than or equal to 1 by 2. Therefore, the answer is option number D. Now let me explain this condition, non-negative. If this value is greater than 3, 3 minus greater than 3, negative values, but you must get non-negative. Non-negative means it can be 0 or positive. So therefore, the maximum value of this will be 3. Maximum is represented by less than or equal. Therefore, I don't have any restriction with this because it is plus symbol. If this is greater than 3, 3 plus greater than 3, positive. Positive by 2 is positive, no issues. But if it is greater than 3, in this case, 3 minus greater than 3, negative. But you must get non-negative. Therefore, this must be at most 3. At most is represented by less than or equal. In that case, we get a less than or equal to 1 by 2. Therefore, apply that condition and this condition, you will get option number D. This is highly worthwhile question. Almost all questions will be giving on directly finding eigenvalues, but this is the most important question, just based on characteristic equation and few basics in algebra. Do not confuse with this A value and this A value. Basically, I compared this equation with A lambda square plus B lambda plus C. So as per this second equation, this A value is 1. This A and this A are completely different issues. Now let us move to question number 50. Just go through the question number 50. Consider the matrix M equal to 0, 1, 2, 0, 1, 0, 1, 0 like this. A 4 by 4 matrix is given and options were in terms of eigenvalues. Option A, M has no real eigenvalues. All eigenvalues of M are positive. All are negative. Some eigenvalues are positive. Few eigenvalues are negative. It's a 4 by 4 matrix, but M is this 0, 1, 2, 0, 1, 0, 1, 0, 2, 1, 0, 2, 0, 0, 2, 0. Now here inside this matrix, the elements are 0, 1, 2. They are repeated many number of times. 0 is a real number, 1 is a real number. All these are real numbers. Therefore, M is a real matrix. And M is symmetric. M is a symmetric matrix. You can look at this. Here M satisfies M transpose property. M is equal to M transpose. It is a real symmetric matrix. Just to transpose this matrix, you will get the same. So here M is a real symmetric matrix. By one of the properties of eigenvalues, we have discussed earlier, all eigenvalues of real symmetric matrix are real. All eigenvalues of real symmetric matrix are real. Therefore, if you go through options, interestingly, in option A, it was given opposite to original statement. M has no real eigenvalues. This is absolutely wrong, because it is a real symmetric matrix. All eigenvalues are real. But in option, it is given against to the original statement. So option A is wrong. Option A is wrong. Now, what is the trace of this matrix? 0. Trace of this matrix is 0. Trace means sum of eigenvalues. Lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 equal to 0. Now look at option B. All eigenvalues of M are positive. Suppose if lambda 1, lambda 2, lambda 3, lambda 4, if every lambda is positive, sum of 4 positive numbers is positive, you should not get 0. But the trace must be 0. Therefore, all eigenvalues should not be positive. So even option B also wrong. Now go through option C. All eigenvalues of M are negative. If all these eigenvalues are negative, sum of 4 negative numbers is negative, but you must get 0. Therefore, option C also wrong. Therefore, option D is right. Option D is right. Write this point. Since M is a real symmetric matrix, implies all eigenvalues of M are real. Implies all eigenvalues of M are real. Since M is a real symmetric matrix, implies all eigenvalues of M are real. Next, since trace of m equal to 0 implies lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 equal to 0. Since trace of m equal to 0 implies lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 equal to 0 implies m has both positive and negative eigenvalues. Implies m has both positive and negative eigenvalues. Now let us move to question number 51. Question number 51. The two eigenvalues of 2, 1, 1p have a ratio 3:1 for p equal to 2. So when they write p value 2, those two eigenvalues maintain the ratio 3:1. What is the other value of p for which the eigenvalues have the same ratio 3:1? What is the other value of p for which the eigenvalues have the same ratio 3:1? Options are like this. First option is -2, next option 1, next is 7/3, next 14/3. See, this can be done in two different ways. When you replace p by -2, find eigenvalues. If they maintain 3:1, then right answer. Otherwise, do the same process for 1, or for 7/3, or for 14/3. Unfortunately, two options are not integer values. They are rational numbers, fractional values. Then finding eigenvalues when the entries are fractional values become complicated issues. Therefore, let us try to solve this equation in a different way. I think question is clear. Now replace p by 2. When p is 2, 2 plus 1 is 3, 1 plus 2 is 3. So sum is 3, one eigenvalue is 3. When p is 2, one eigenvalue is 3, but 2 plus 2 is 4, already 3 is covered, so second eigenvalue is 1. So they maintain 3:1 ratio, that is clear. They were asking what is the other value of p for which these eigenvalues maintain the same ratio 3:1. Let us see. So sum of eigenvalues is to trace. Assume that this matrix is A. So two eigenvalues, I call them as lambda 1, lambda 2. Sum of eigenvalues equal to trace. Lambda 1 plus lambda